All right, well, welcome everybody. My name is Nick. I'm with the Graph Foundation. It's my honor again to step in today and help host today's Indexer office hours. Abel's away with GraphOps, who typically not only hosts these meetings, but does a far better job than I do. So I'll try to step in today and just want to welcome everybody. We're super excited to offer today's content, and it'll be very useful for everybody here. So for anyone that's new to Indexer office hours, this is a town square of sorts for the Indexer ecosystem to come together and discuss more important topics relevant for Indexers. So we'd love participation. You can unmute yourself or type in the stage chat, and we can have some dialogue going there if you have a question. And for those that need this reminder, there's a 30-minute Q&A planned for the end of today's presentation for anyone in the MIPS program that would like to get some very specific or unique advice or education. So stick around at the end of Indexer office hours for a 30-minute Q&A. As a reminder, this session is recorded and it will be distributed via public channels like on YouTube, so be aware of that. And we have a really great agenda today. Typically, we have some repo watch updates from Anna and protocol watch updates from Juan, but we don't have anything to share today, and the team at GraphOps will be sharing more in the coming weeks. So we're going to skip that part of the agenda and go straight to Pedro with the Graph Foundation for some updates and announcements related to the MIPS program. So Pedro, I'll turn it over to you.
Okay, very cool. Thank you, Nick. Let me know if you're hearing me well. I've had issues with Discord and my microphone before.
We're good to go.
Yeah, perfect. Thanks. So yeah, there are some updates, and I've been meaning to share this officially 24 hours ago. So apologies for the delay, but right after this call, we'll send the official announcement, and we'll also post it in the Discord channel. There's just been some recent developments that we had to pause this announcement. But to answer the first question around, and we've shared this phase one timeline before, and officially it should be ending now, but it is still going, and it will go at least for another week, meaning this week and the following one. There's been some testing around subgraphs that rely on traces, and we were hoping we would solve this issue during this phase one. Maybe Payne can talk about this later, but essentially subgraphs that rely on things like call handlers, which are not really recommended anyway. But subgraphs that do rely on it are extremely slow to index at the moment with the execution client that you've all been using, like the Nethermind client. And there's been a plugin built by one of the Nethermind lead devs, which would allow us to create the traces while at when we're processing blocks. So you would have a dedicated database for it, meaning that once GraphNode was indexing these things, it should be much faster. At least as fast as Open Ethereum as an alternative client. But it turns out that using this plugin is still a little bit slow, and we were just wondering how we should move forward with this, because activating this on mainnet would mean that anyone could publish subgraphs over, and if they did indeed rely on these, indexers might have a hard time syncing their archive node. So I think we'll need a couple more days to figure this one out, or at least have a plan to activate it on mainnet, knowing this caveat. We're working very closely with the Nethermind team now, and in the future we may have ways of testing it. But for now, the subgraphs in scope are the ones we've shared before. Please continue to serve them for a couple more days, at least. We're hoping two more weeks, as mentioned. And yeah, that's the first topic. The other thing, I've been noticing some questions around, or we've been noticing some questions around the 200K GRT as the cap. Some folks have been saying, based on the indexing rewards I'm now getting, should I reallocate? or restake them. So you can definitely, the rule of thumb here really is please just do not go over 200K when it comes to the allocated stake, the total amount, because that's how the ISA would penalize you, because or rather our monitoring with you would be penalized by doing so, because the ISA should treat you differently, and that's not what we want, not at least for this phase anyway. So I hope that clears things out. And indeed, I think we mentioned something like economic security being taken into account, and that was not correct, because that refers solely to the slashable stake, which we're not looking into it right now, really. So moreover, a quick update also on gas, on 𝗨𝗟𝗂. It seems to be pretty spiky, as you might have seen lately, super volatile, I mean, and 𝗨𝗟 is scarce. So yeah, again, do monitor how you're managing your allocations just to save your 𝗨𝗟. The foundation can still distribute a little bit more during the following days, but it's not like we can do much there. So just a quick warning. And I've also updated the Notion page, highlighting 2 faucets that have been working fairly well these days. So yeah, you might want to use that faucet every day as well, or every other day. I don't know how much 𝗨𝗟 you will need, but those 2 are working fine. Last one on the leaderboard, it's coming. It's something that you're all looking for. We are as well. We're getting ready, and I don't want to commit to any deadline again, but we're hoping to share it in the following 2 days. So yeah, be on the lookout. We'll be sharing another official update once that's live. What else? I think I can finish off with this new announcement, that something that's will be coming from Gnosis Chain, the team themselves. They will be announcing something for MIPS participants. I think it's sounds like an exciting announcement, but I guess we'll know more soon. But yeah, it's good to know they are helping out. It's a win-win situation, both for our protocol and their own chain, obviously. And and again, based on this discussion around the Nethermind and the quote on like not really issues, but this indexing speed issue with subgraphs relying on things like call handlers, we'll have a plan to start moving this to mainnet once we monitor QoS and we do the proper analysis there as well. So again, hopefully early next week we can share more on this, or the plan for it anyway. So yeah, like I said, phase 1 is still active. That's the most important thing. I hope that's it. I'll take a look at the chat now.
Thanks, Pedro. So if you have...
Yeah, I'm sorry, Nick. I was just going to say that we also have Ford on the call, so I don't know if Ford wants to jump in and say something if I've missed anything.
Can you guys hear me?
Yep.
Okay. I wanted just to add a bunch more details on the Nethermind trace filter stuff. So currently, with the current latest release of Nethermind, well, whatever I'm using, it's like once you try to sync up subgraphs are using trace filters, your disk utilization and CPU goes up through the roof. So with only one single subgraph, I was getting 70 to 80% CPU utilization and close to 2 gigabytes per second reads on my disks. This is just one single subgraph that's using the trace filter. So this is definitely a no for having this in production. And the other problem is with some changes that were coming from Nethermind, we were able to start a resync of the Gnosis chain node through Nethermind, this time including the TraceDB. But the only issue is that it's going to take months to sync up the chain head. So again, that's assuming they manage to fix it. I don't know what the options are, but it's not looking great right now. But that's about it.
Pedro, Ford, do you want to add anything there? I do want to remind everybody that we will have a 30-minute Q&A to follow this indexer office hours that's specific to MIPS. So maybe we can hold questions there. But before I move on, Pedro, Ford, anything to add?
No, nothing to add right now.
Yeah, I'm also good, Nick. Maybe
Great.
follow up during the Q&A.
Cool. Thanks, everybody. And thank you, Payne, for stepping in there. We'll see all of you for the Indexer Office Hours. I'm sorry, the MIPS Q&A at the end of Indexer Office Hours. So let's go ahead and get started with today's main presentation. We're excited to welcome Kai. Kai is a DevOps engineer at Semiotic, which is one of the core dev teams working on the graph. So he's primarily responsible for operating the Semiotic indexer and all the Ethereum infrastructure. Kai's a regular here at Indexer Office Hours, so most of you will recognize his voice and really appreciate him taking over today and providing an important training for everybody. So Kai, with that, welcome, and the time is yours.
Hi, thank you for that very nice welcome. Give me just one moment as I switch off push to talk.
No problem. Abel, we are recording.
Okay, can everybody hear me okay?
Sounds good.
Excellent. All right, so thanks again. Once again, my name's Kai. I'm the senior DevOps engineer here at Semiotic Labs. I've been working here since the very beginning of this year, and I primarily work on our indexer as well as our Ethereum infrastructure. I also am a core dev contributor. I've contributed patches to the graph node as well as to the indexer stack. Most of the work I've done in those spaces has to do with easier configurability of those stacks. So without further ado, I'm going to just go ahead and share my screen. I just want to make sure everybody is able to see that. Can you guys see that okay?
Looks good to me.
Excellent. So the presentation I'm going over today is primarily around declarative infrastructure. Now, one of the first things that we noticed, one of the first issues we had was a set of 3 challenges that really got us when we were running our indexer. The first was establishment of monitorable services. So as you guys know, running an indexer, it's important to have some amount of monitorability of your service. The default stack includes a Prometheus instance, and you can get some decent metrics that way. Of course, another challenge is actually being able to understand how your infrastructure works. For instance, if you're working in a somewhat large team like where we are right now at Semiotic, it's important to be able to hand off the infrastructure from one person to the next. Say somebody goes on holiday, gets hit by a bus, whatever. It's important to have that all documented and well laid out. And then, of course, whenever you're operating something like an indexer, you have this zoo of sensitive information you're dealing with. You have mnemonics, indexer addresses, any number of Ethereum endpoints that you might not want other people to be able to touch. So we spent a lot of time tailoring our infrastructure using declarative infrastructure. Now, our primary tools of choice are Terraform and Kustomize. This is very similar to how the repo the repo provided by the Graph team does it, but we've taken it to a whole nother level in that we have multiple namespaces, we can support multiple chains, and we're able to resolve a lot of this chaos with just simple code. So we terraformed literally everything. Well, almost. We're getting there. We still manage our software stack with Kustomize. But why? It's fully declarative. You can just check out the repo, read through the manifests, and actually see the infrastructure. You can create a diagram from there. It's self-documenting. You look at the manifest. Okay, we're running a Kubernetes cluster that drives itself. It auto scales, and it's all written right there in the manifest. You can almost read it as if it were English. It's also accessible to our other team members, which is great because especially if you want to stage changes to your infrastructure, you just simply send them your GitHub link and say, hey, can you check on this? Just make sure I'm not doing something dumb. So it gives you a little bit of peace of mind. You can also finally control your secrets where they're visible and also reduce the secret usage or the leakage of it. Because instead of hard coding secrets somewhere in your infrastructure or setting a variable and just hard coding it into a Docker Compose file, you can abstract that out and then store those secrets on an encrypted medium. So our DevOps workflow is actually very simple because of all this. Similar to how you would in a standard development flow, you propose a feature. If you want to bolt on a new piece to the indexer infrastructure, create a feature branch. Then you write and edit your manifest files that represent the changes you want to make, include any customized files which may represent your software stack, and then you commit, validate, review, and revise until everything is set, and then you're ready to apply. So if we go ahead and take a look at what that looks like, let's go ahead and take a look at our demo. So I've created a small demo here. And this is an idea as to what this would look like. We have configuration for a database, the cluster itself, some networking, as well as the Terraform values themselves. So let's go ahead and take a look first. Let's go to backend create. What this will do is this will source to the Terraform values up here, as well as the variables, and it'll create a bucket within, in this case, we're using GCP, that will store our Terraform state. Now this is important that it goes into the bucket. And the reason it's important that it goes into a bucket is because that way, any changes that are made by your colleagues are then recorded within the infrastructure. So let's take a quick look at this. So to create this actually creates the back end of Terraform itself. This sets up your cloud account. You could drop in any API provider you want. In this case, we're using GCP. You could use this with Azure, AWS. Anyone you have a Terraform module for, you can use that cloud backend. So in this case, we do everything declarative. The resources that we need access to, the bucket itself. So all we have to do here is to do Terraform. Let's see, is it validate? I think it's validate. Terraform validate. Okay, configuration looks good. We'll go ahead and apply that. Let me just make sure that I'm on the right project here. Okay. Let's see, let me just make sure I'm on the right project list. Should show me the current project. Okay, that's that. Let me just make sure that so I don't want to apply this to our production, obviously. Okay, perfect. So it's going to apply to that. So what the Terraform values look like. So you can see here, we have a more complex data structure down here. We'll look at that here in a minute. So we're going to go ahead and do a Terraform apply. All right, so this will go ahead and create the bucket, and it'll establish the access to the required APIs. And you see, we're done. Now in this case, it looks like I have a bucket created already, so we're pretty much good to go. We're going to go back up to our home directory for the Terraform. And let's go ahead and take a look. First, we're going to take a look at the cluster configuration. So you can see we're using the Google provider, and we're also using a Kubernetes provider. This helps to set up our cluster, and this sets up our gcloud client config. Now this is, of course, you're going to use different data providers depending on what cloud provider you choose to use. Now there's a whole set of different cloud providers available to use. If you go over to registry, 𝗨𝘀𝗲𝗂𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 and I can't spell it, but that's okay. So terraform.io. So for instance, you wanted to use Amazon Web Services, maybe it's under AWS. You'll see here, go to the documentation. You have all kinds of nice guides that will walk you through exactly writing the exact same manifests as you would need to see for setting up GCP provider. So if we go into this further, we set up our cluster, and you'll notice here that we're actually creating the networks on the fly. So once we go to set up this cluster, it's going to grab the subnet definition from this variable here, and it's going to drop it in. So you literally just declare everything just like this. So we're going to go ahead and do that. All right, we're going to go ahead and validate it first. Looks valid. Well, let's go ahead and plan it out. Now this will actually visualize your changes. Terraform plan shows you what's going to happen. Now, a lot of people that start off with Terraform will go ahead and just type in their secrets just as is. And that's fine, but that causes some issues. For one, you're generating secrets by yourself. That's never a good idea. Two, you're actually recording those secrets in places where they don't need to be. You know, a workstation hard drive, a flash drive, God forbid, something to that effect. What we do here, and as you'll see as we go through this planned out Terraform, is we actually generate these secrets dynamically. So you'll see here it's pulling in a range that's set from the variables. But then if we go further down, creating a network and all that good stuff. But if we go down towards where we start to create databases and database clusters, you'll see that what we're actually doing is setting that dynamically. Now let me go ahead and find that here. All right, so Google SQL database will be created. It's called Graph Mainnet. You'll see the project self-link. Well, now we're going to go ahead and create a couple of users. And you'll see all this is known after the apply. The password's a sensitive value, still known after the apply. Project, name, all known afterwards. And let's go ahead and take a look at how that's actually done. So whenever we go to generate secrets, oh really? Whenever we go to use secrets, there's some that we can generate and some that we cannot. Secrets like connections to your Ethereum infrastructure, you gotta know what those are. And Terraform gives you a mechanism by which you can actually log that. So let's go ahead and take a look at the database password. So we have the Postgres credentials right here. And we'll see here that it sets, okay, the user is Graph, that's fine. But the password, well, we don't really care what the password is. So we just care that the password is correct. We don't need to know it. We don't have any reason to use it. And therefore, we use a module that generates it for us. This module, the random password module, is declared right up here. So if we take a look, we use the resource random password. Now this is built into Terraform. This you can use with anything that needs a password. You set it a length, we actually generate the password length dynamically as well. We enable it to use special. I chose to override the special characters with just 3 characters because it's used in the URL and because Postgres. And then this feature here, this is called your keeper value. Now this is important for when you go to reapply configuration changes later. The keeper value enables you to set a mechanism by which to determine when to reset the password. So for instance, if your password gets compromised, somebody manages to sniff it out, all you would need to do to rotate that password is to simply toggle this value to a new value. You'll see here that refers to var.indexer, and then once you change that, it'll rotate it around. So let's take a look at a little bit more as to how we actually do this as well. I'm going to switch back over to the presentation here. I cannot see the questions, so well, let's take a look, see. All right, none of the subgraphs. All right, cool. So again, secret value generation, you can generate even more advanced resources. For instance, you have your free query token as well as your HT password, which you might use to secure your endpoint for the MIPS program. Now MIPS, we're actually having to expose our entire endpoint with no authentication. So it's not ideal, but hopefully that can be resolved in the future to where we can secure that. Once that's secureable, you can use something like this to generate an HT password to inject into your endpoint. So in this case, what we're doing is we're using a null resource to essentially transform the random result that we get into an HT password. Now you see here on line 61 through 63 that we're ignoring changes to the HT password. And the reason we do that is because we're using a function here. And this function is called bcrypt. There's a whole suite of functions that you can use within Terraform: join, bcrypt, cat, concatenate, any number of different routines. Now the thing with bcrypt is because it implements a salting mechanism, every time you go to apply, it'll rerun this function here. And what that'll do is it'll regenerate a salt. Well, that's not great, because one of the things that we want to be able to keep track of is when we actually make changes to the infrastructure, not just when a salt changes. So one of the things we do here is we actually add a trigger that tells it, okay, ignore any changes to the HT password. So that's really nice. That enables us to really just change things on the fly, but actually understand what's changing. So that gets incorporated into part of our review process. Just the same as secret declaration, you can also declare resources. Again, we're declaring a couple of databases, so this will actually hook into your SQL database instance that we create further up, and it'll actually create the databases that you need. In this case, we're creating two. We're creating graph mainnet, indexer stack, and we're also creating an account, again using the generated credentials. Now we actually use the result of a Kubernetes secret creation. The cool thing about Terraform is it will actually resolve all these dependencies and reorder the creation such that everything is created in the correct order. So what will happen here is it'll go to create the Kubernetes secret first, source the data in, and then throw it into the database created. And this is something else that often comes up, and it's going to become more prevalent in a multi-chain world. There will be instances where you need to share secrets across clusters, across namespaces, and across any manner of different divisions. Now here at Semiotic, we're running 3 different chains. We're running a testnet, chain, we're indexing a testnet chain, mainnet chain, and like everybody else, we're also indexing Gnosis. But one of the things that we wanted to be able to do was to share the authentication credentials for a couple of things across all these namespaces. Now we divide each one of these chains into its own namespace, but we have a metrics collector, a Prometheus instance just like you. And we want to be able to lock down that endpoint so that way anyone that has access to the cluster can't just start scraping credentials without any authentication. So we create this resource, but now we got to reproduce it. So we use this for each here. And what this does is this will declaratively reproduce this secret where every value that's within this variable called all namespaces gets split apart, duplicated, and assigned to each namespace with this definition here. So if we take a look at the Gnosis namespace, if we take a look at each one of the namespaces in all namespaces, we'll see a secret called metrics auth, which is really, really, really useful. Now, of course, we can take it the other direction as well. Using complex data types and objects, we can split secrets apart such that each namespace gets a different value for its secret. If we, again, using the multi-chain example, if we wanted to assign a different EVM endpoint to each namespace, we simply key the endpoints based on the chain name. So in this case, the for each will iterate through this list of indexer RPCs, and it'll assign the indexer EVM secret value to each value encountered within that object. And we'll take a look at that here further in a bit. So let's go ahead and take a look at that now, actually. But before I continue, I'm going to ask if there's any questions. All right. We'll just continue on then. All right, so let's go ahead and take a look at that. To take a look at this, we're going to need to see two of these in concert with one another. So we're going to take a look at the variables and the secrets side by side. Now, looking at the secrets, we're going to go down to where we actually define our EVM endpoints. So we actually separate the EVMs a couple of different ways. We separate them into transactional EVMs and indexer EVMs. The reason we do this is this allows us a little bit more flexibility as far as what RPC we want to use with the indexer agent versus our index, the indexer itself. So if we take a look at the variable definition for the transaction RPCs, you'll see that we define this as an object with RPC URL and the namespace that we want to associate it with. And the description, of course, is a set of EVM compatible RPC endpoints. Now, if we go ahead and take a look at the actual definition, you'll see that right here. So let's go ahead and move this on over. So our loop will then go through each one of these. It'll take this key and say, all right, excellent. We're going to assign that to the, we're going to assign that as the network name. And then we're going to take this RPC URL and we're going to assign that as the RPC URL for the secret. And of course, each namespace is specified right here. So our mainnet would operate in the default namespace. The Gnosis endpoint would operate in the Gnosis namespace. Now, if we take a look here at get secrets for the namespace default, you'll see that indeed we have an EVM. And now we have not applied Gnosis yet, so if we take a look, oh well, we have. All right. You'll see the secrets are the same, but the values are entirely different. Now we're looking at the production, so I'm not going to actually expose those secrets right now, but you can see here what will come out is two different secrets. So if we go ahead and apply that, it'll go through and actually set up all those secrets for us. So if we look here, you'll see namespace Gnosis, and it'll send in the sensitive value. Same too with the mainnet. Again, it'll set a sensitive value, but it'll set two different values, which is great. Now we have two different ways to apply those, which is fantastic. And it's exactly what we're looking for. So to source those secrets from Terraform, it's as simple as referring to a secret just the same way as you would in any Kubernetes environment. So in this case, we're taking a look at the EVM RPC URL, and we're pulling that in from the indexer EVM secret with the key of RPC URL. Again, that refers directly to this value right here. So you can begin to see the correlation here. Once we create the secret, it'll create a dictionary with those values, and it'll pull it straight in to the Kubernetes environment and assign it to this secret. Thus, we have containment of all the secrets that we need to maintain, and we generate those that we don't really need to have a knowledge of. For instance, the Postgres password. And now we do that. We pass these secrets to a couple of different places. We pass it to the Graph shell, pre-configured so that the pSQL client can actually connect directly to the database without any problems. Again, it helps to reduce the sharing of secrets across the cluster. It helps to at least put it out of view. And now we go on to the next stage of our journey. We have monitoring set up like everybody else, but the next big stage in our monitoring is going to be with something called 𝗨𝘀𝗧. Again, this is going to be set up using Terraform. So again, it's just, with this one, we went really bananas. We absolutely went totally nuts. But before we go into that, let's take a look at the architecture of how 𝗨𝘀𝗧 actually works. So within 𝗨𝘀𝗧, now of course we know with Prometheus that you have a time series database. It's capable of storing between 30 and 90 days worth of data somewhat reliably. After that time, it starts to have some issues. You begin to notice breakdowns. Also, whenever you go, also the database gets pretty big pretty fast. So what 𝗨𝘀𝗧 does is it takes all those different databases from all those different Prometheus servers, and it aggregates all that data into an object storage cluster. Then it indexes that data such that Grafana API clients, instead of connecting directly to your Prometheus server, will connect to a query front end that then queries the object storage. So from here, you can also assign different rules. You can assign different alerts. All these different components all run in different containers. So yeah, you can start to really build up your monitoring infrastructure pretty nicely. There's some other mechanisms over here to compact the data and reduce it down such that your archival data, you might have an interval of every 5 minutes as opposed to every 5 seconds. So that way it helps to manage your storage load really nicely. Of course, how are we going to deploy it? Well, Terraform. Just like anything else. As you can see here, we go really bananas here. Instead of going with, assigning some customized files and, tweaking everything that way, we took everything into Terraform and started using that to employ Helm charts everywhere. As you can see here, we pull in a good chart from our good friends over at Bitnami, and then we set up everything through that. Now, this is still a work in progress. We're still evaluating 𝗨𝘀𝗧 to see, exactly what we can monitor and what we can do with it. Right now, we have data coming in from all of our Ethereum endpoints, as well as our indexer. We have yet to assign dashboards to it yet, so that's still a work in progress. But if we take a look over here, again, we're using yet another module within Terraform. So we're using a resource called Helm Release, which then you can plug it into any repository you like, including the work that's been done, the excellent work that's been done by GraphOps. You pull in their Helm charts and begin to set up all the Helm chart config values that you need. And then, just like the previous workflows, Terraform validate and Terraform apply, and away you go. And so that's where we're at right now. So that concludes our presentation as to how we're doing that. As far as recommendations for somebody who's unfamiliar with Terraform, the best thing, I don't know if I would do an online course. What I would do is I would actually start with their resources. Terraform, if we go to Terraform, has a really nice couple of readmes that allow you to that really get you started here. So let's go ahead and take a look at that just real fast. Yeah, if you take a look at their getting started guide with AWS or GCP, those really help you to understand how that whole thing works. So it goes over how to set up the project, goes over how to generate some of these providers. There is even some generators that you can download as additional modules. So I'll go ahead and link this into the chat. Yeah, I can share a link to the presentation. I hope it will be useful, but yeah, I can definitely share that.
Thanks so much, Kai.
Most welcome.
I think you're still sharing your screen. There you go. Close stream. Perfect. All right. So here we are at 45 after the hour. We're ending 15 minutes early. Maybe best practice is to allow anybody that wants to ask a direct question to Kai about anything he just presented on can do so now. We can do maybe 5 or 10 minutes of questions. And then once that concludes, we can roll into the 30-minute Q&A for specific to the MIPS program. So why don't we just take a minute here and see if there's any questions for Kai? Feel free to unmute yourself or type it in the chat. Not seeing anything happen in terms of questions. There was a post that just went in there. So maybe what we'll do is we'll roll into that 30-minute Q&A for MIPS participants. So before we do, Kai, just want to say thank you very much for your time and for putting together such a great presentation. It was super helpful, and I'm seeing a lot of positive comments here. So thank you to Kai and the team of Semiotic for doing that. And Slim, I'm proposing that we end the recording and then we can start the recording for the 30-minute Q&A, and that way we can break them off on the back end. Is that okay with you? All right, so we'll conclude the recording for Index or Office Hours. We'll see you all next week. Thank you for joining us.